So yesterday we did optimization, but we did optimization for 2D problems, right? So it was area and perimeter. Today we're going to do optimization, but for 3D objects, okay? So we're going to be dealing with volume and surface area. So the same thing that happened with us yesterday with respect to the rectangle, right? It was the one that gave us the minimum area and the minimum perimeter was a square. It's going to be the same thing with a 3D shape, but to put it in a 3D shape, a square is a cube. Okay? So anytime you want to maximize volume, minimize surface area, you're going to use a cube. Okay? So among all rectangular prisms, this is only when we have rectangular prisms, right? There's other shapes, but we don't do them in this course. Among all rectangular prisms with a given surface area, a cube has the maximum volume. So we're going to be maximizing volume. All rectangular prism with a given volume, a cube also has the minimum surface area. So you're going to maximize volume, you're going to minimize surface area. Let's start with.
It was square.
It was square before.
Was a cube.
That's right. Now it's a cube. Now, let's look at the formulas of cube. They're not in your green Duoteng, okay? But we can find them. Okay, they're not hard to find. So, if we're talking about a cube, right? All sides are the same. So if this is A, then this is A, right? So that's what a cube is. So if the regular volume of a rectangular prism is length times width times height, what would it be for a cube? That's right. A times A times A, which is?
A cube.
A cube. That's right. Okay? So if we're dealing with a cube, we're going to use the formula volume equals A cube. We're going to forget about V equals L times W times H. Now, can you guys look at the surface area of a rectangular prism? Rectangular prism. So what is the surface area? So if you're talking about a regular prism, so this is L, this is W, this is H. So it would be 2 times LH, LW, and WH, right? Because you have two sides that are equal. So let's say if I take this as my rectangular prism, right? And I have my length and my width and my height, right? If I find the area of this, it's twice, right? Because back and forth, front and back. Then I have the area of this and the area of that, they're the same, so I have two of them. And the area of the bottom and the area of the top, right? When it comes to a cube, on the other hand, what do I have? 6 what?
6 faces.
6 faces, and the 6 faces are exactly the same area, right? What's the area of this face? A times A, which is?
A squared.
A squared. I have 6 of them, so the surface area is 6 A squared. Right? Because the area of one face is A squared, I have 6 of them, so that is 6A squared. Okay? So anytime you're optimizing, you are using these formulas. Optimizing cubes, right? Now, if you are given the volume, then you have to use the volume formula to solve for A, and then you use the surface area formula to solve for the surface area. like yesterday. If you are given the surface area, right, you have to use the surface area to solve for A. Then you plug in the value of A in the volume and find it. So let's look at the first question. So what dimensions a minimum surface area of a rectangular prism with a volume of 1,000 centimeter cubed?
Minimum surface area. So first we got, let's see, 6 is
What is given to me?
volume.
The volume is given. So since the volume is given, I have to start with the volume formula. So the volume equals A cubed. The volume is 1,000. Do you guys understand that? So I start with the given information. How do I solve for A? Yes. Yes, cube rooted, right? So the opposite of cube is cube root. So you have the root with a 3 on top of it. Right? Do you guys know how to put that in your calculator? It should not be 94.
Yeah, I got
First push shift,
You should be getting
then
10.
under root, and then 1,000. So it's 10.
Here, show me. Should I? Got it?
The difference between value, can you go down?
Yes.
The difference between volume and surface, this one, the volume is just like avoidable. When you see the layers, 3 layers, the volume, the surface is even the, we collect the hidden bits, right?
Volume is what you can fit inside of it.
Volume's like the
It's how much, no,
matter.
it's how much you can put inside of it. How much space does it take? The surface area is how much do you need to cover it from the outside. You don't count the inside.
Okay, so the difference between this one, volume, how much, what's inside?
Yeah, so let's say if I ask you what's the volume of my coffee cup, right? So how much coffee cup does my cup hold? Right? So it's what you can put inside of it. How much can you put inside of it? Okay? However, the surface area is,
Two sides, right? Yeah. With the
cylinder you have to do pi r squared h. No?
Okay.
Okay, I'll come and explain to you in a minute, okay?
Yeah. I don't know how positive one with this equation, or with this equation right here. I
Oh,
got
yours is back.
separating and negative.
Okay, 1,000.
I mean, this one, you see, difference between those, the volume, just when you see like 1, 2, 3, it's not fitting, you know what I mean? It's
Yeah.
divisible. But the surface, we collect even the
-1.
hidden phases, so the other phase this way. So we collect this one, and we 2, and we have the other one, and 3. So for total, it's 6 space, right?
Yeah.
So we collect this 1/6.
Yeah.
But
Yours,
we
you can do this for free, but you want to
But
find
it's
it.
because,
Okay.
I was thinking that this is huge, I think it's, you know how the 3 is huge,
Sometimes you have to
that
do more
is
than
This
two.
comes off.
Yeah, so
But
each
if
of
it
them
comes
comes-
at the
Okay,
comes
If
in the,
you did 8 cubes, it would solve for the whole cube. That would be all.